All right, welcome everybody. This is the object bucket storage KEP review, date 9th of July 2020. So last week we did not meet, due to the U.S. holiday, and I just wanted to go over a recap real quick to kind of refresh people on what we talked about in the meeting prior to that. There were some pretty big discussion points, and I want to make sure we're all still on the same page there. So first, with the Cozy CSI driver, so this is the adapter between Cozy and the kubelet as a means of injecting credential and connection information directly into the pod's file system. You can see that here. You can see in the lower left section, we have the Cozy adapter. It'll communicate information from the bucket access and bucket API instances through the kubelet into the pod. That enables us to, one, not have to copy credential and connection information into config maps and secrets, which is a bit of a arbitrary design. It doesn't give us a lot of control over how we're distributing this information. It also allows us to block workloads from starting innately until provisioning is complete, which is a really nice feature that otherwise we would end up placing the burden of onto a user by forcing them to define a secret name, define a config map, and follow that kind of messy workflow. So to point out one thing, there were some security concerns about the Cozy driver having to reach into application namespaces and being given RBAC access to bucket access requests and bucket requests. The need for this is so that pods can reference the bucket access request that will ultimately dereference to their connection and credential instances. And that dereferencing has to begin here. So the Cozy CSI driver, or adapter rather, has to be able to read those, dereference the bucket access, and then ultimately the secret, which would still be stored in the provisioner namespace. It was determined that while this is a bit of a security concern, given that this is a stopgap measure with the end goal being actual implementation in the kubelet itself, that it's acceptable for now in order to kind of demonstrate that the system works. Let me see here. Let me kind of scroll back up.
So I have a question here.
Yeah, go ahead.
Have we agreed on what the method is for us to present the credentials to the pod?
Yes. So the method is going to be via CSI ephemeral volumes.
So I mean, like, is it environment variables? Just a file, right?
It's going to be just a file. The unfortunately, I don't have my kind of example spec that I wrote 2 weeks ago up, but the user would define their pod and specify. I'm kind of assuming here, but we haven't defined a process for it. Define 2 CSI ephemeral volumes, one for their connection data, one for their credential information. The reason that I separated this out was credential files are pretty common practice for the big SDKs.
Yeah.
You know what I mean? So like, yeah, it's pretty common. They all write to a file and can read from a file. Connection information is pretty arbitrary. That's going to be defined by us. No SDKs really support reading bucket endpoint information from a file.
So really, we're talking about a secret that the CSI driver is going to pull a secret, and then it's going to mount it in the pod.
Correct. Yeah.
So with so in terms of the RBAC access issues or concerns that we had, if you're only pulling a secret and if you're only waiting for the bucket to be created, do we still have that issue?
The RBAC concern, as I understood it, I went back and I had to re-listen to the meeting to make sure I had everything right. But it was mostly about giving like get list watch permissions to the driver to get list and watch the bucket access request and bucket request in application namespaces. The access credential secret should only exist in the provisioner namespace. That could be a bit of a concern, but that at least can be narrowed down with RBAC. So you can say that they can only access these secrets in this namespace. You don't necessarily have to give them full cluster-wide rights to that. So we can mitigate it in that way.
Yeah. So where I was coming from was it might be possible to never have to get a bucket or a bucket access request for the CSI driver. In the sense, it doesn't have to listen in on events for those. The reason being, the CSI driver is going to be called after the pod is scheduled, and it needs a volume. And we would have requested this volume in the pod spec itself. So say the request comes in, and then on, I think the method is called publish volume or maybe mount volume. When that is called on the driver, can we then just list for the bucket that we were interested in, and if it is found, we can assume that it is it's available. Then we look for a secret where we have the namespace credentials or authorization for, and just work with that. Just mount that in the pod.
I think that that's doable. The one, and I don't, let me put it like this. I don't really know how big of a concern it is. So I'm open to hear it, but the reference path from the user point of view, I'm thinking that when I'm defining as a user, I'm defining my pod spec, should I have to know the name of the bucket object or the bucket access object? Or should I just have to know the name of the API objects that I created?
I don't think this works, right? Because you create those requests which might end up provisioning the bucket. So there's an ordering problem here, right?
Mm-hmm.
So if I have a workload definition that includes bucket requests, that entire, I have a multi-chain thing that I have to stop. I first got to satisfy the bucket and bucket access request provisioning to create those cluster scoped objects. And then I have to do the ephemeral volume, and then I can run the pod, right? So there's a multi-stage piece there. I don't think you can presume that the bucket exists before the CSI driver has to be able to get the credentials. It's got to be able to block on those.
Yeah.
And it can, right? So the CSI driver can hold off on effectively the mount call until all the things that it needs in order to complete that mount call are ready.
But to do that, it's got to sort of continually check to see if those things are there, right?
Yes, and that's exactly what kind of today, that's how things operate. So if any component within Kubernetes has a dependency on another component, it effectively just sits there, polls, waits for it to get ready. We use informers, so it's a little bit more efficient, but that's basically how it works today.
Will the that blocking, that waiting occur in a single, within a single stack of the node publish volume call? Like, will that call block until it's ready, or are we expecting the kubelet to keep polling node publish volume?
It should block.
It should block. Okay. So back to the point then on whether or not the CSI ephemeral volume should reference the code namespace objects or the cluster scoped objects. Where do we sit on that? My stance has been up till now that it would reference the code namespace, user generated objects.
Sorry, can you repeat that? Sorry, I didn't follow.
Yeah, so the right in here, so this line kind of is maybe explaining better than I am what I'm trying to say. So the ephemeral volume has a string map, and we're going to use that to allow the user to point to the bucket access and the bucket that they would like injected into their workload.
Mm-hmm.
So The way I've envisioned this, or rather that I'm proposing, is that they would just make reference to the objects that they themselves have created. I know the name of my bucket access request and my bucket request. I would stick those in my string map with keys defined by us, the cozy authors. And then that would be passed to the CSI adapter, and it would use that to dereference the cluster scoped objects.
What's the alternative to that? Isn't that the only model that makes sense?
Mm-hmm.
I think, so maybe I misunderstood what Sid was saying. Because I thought, Sid, you had said that why not just allow the user to define the cluster scoped objects by name? Is that what you were saying, or did I just misunderstand?
No.
Okay.
So yeah, what he's saying was slightly different. What he's saying was we could get away without giving CSI drivers all the permissions that we originally thought we had to.
But all of the permissions, I mean, it needs the permissions to both see the local namespace access request, because that's what they're referencing. And then it needs the permissions to be able to see the cluster scoped objects that derive from those. And those are exactly the set of permissions I think we've been talking about all along. I don't know how you whittle that down.
And the credentials.
Well, the credentials are associated with the cluster scoped objects, right? Those are placed in secrets in that same cluster scope or provisioner namespace, right?
Yeah. Oh, yeah. Provisional names. Yes.
So is that is that what you're talking to? Do you think that might be problematic?
So what I was saying was, if we had a standard convention, say a secret name, because buckets are cluster scoped and they're uniquely named, and since secrets are going to be in the provisional namespace auto-generated, we could have a secret name matching a bucket name. That way, if you just knew the bucket name, you'd be able to get the secret, and you wouldn't need access to bucket request or bucket access or a bucket request resource.
You do, because you're not putting all of you're effectively, I think, suggesting that you copy all of the details from the bucket or bucket access object into the secret. I don't think that was the thought. The thought was that you would only put credentials in there, but all of your endpoint information, all of your structural information would still be in the cluster scoped objects.
I see. So secret just has access key and secret key, probably.
Yes.
Probably it's endpoint too, but yeah, that's about it. That makes sense. So is that really a concern, the RBAC issue, where we're worried about giving the CSI driver too much access?
Well, the point we ended on last meeting was that it's an acceptable model, given that the CSI adapter is kind of a stopgap, with the ultimate goal, hopefully, being that this code is actually written into the kubelet itself, and so that the kubelet, a trusted entity, would have the RBAC rights to read these namespace objects and write the information directly into the pod.
Right. So the key being here is that it isn't that it would require any less access. It's just that it would be a core mainline part of Kubernetes, and therefore we trust it more with these higher.
And in addition to that, the API server has something called a node authorizer, which limits access to secrets from the kubelet. So it kind of keeps a map of which node should have access to which secret. And so when it gets a request from a kubelet, it will authorize or not that secret.
Ah, cool. Okay.
Yeah, I'm not. How does that work? So say there's a secret that exists for a bucket, and the pod requesting this bucket exists on 4 out of the 10 nodes. What would the node authorizer do?
So today, the node authorizer kind of just looks at first level, what are the secrets that a pod is referencing?
Okay.
And I believe it also looks at PVCs and dereferences those as well. So if there's a secret that a PVC is pointing to, it can authorize that. So similarly, you can imagine we update this logic to handle bucket request secrets.
So you would have to do the 2-level dereferencing to get to the secret name, and then you would auto add that to the node authorizer, basically?
That's my understanding. And so the node authorizer would have logic to say, hey, when I look at a pod, if it has one of these special bucket request things, let me dereference that and figure out what it's pointing to.
Hmm.
I mean, I guess I'm not as worried, I guess, about the RBAC concerns that we're talking about here, because this is not privileging the provisioners, right? This is not third-party code. This is privileging the main controllers for this. And so it is essentially a kind of a Kubernetes component. It's just not, you know, mainline core. But
Yet.
so the main issue, I guess, well, but even then, if the credentials are in the provisioner secret, then even then, you're not even giving blanket secret access to that. You're already giving sort of targeted secret access. So I guess I don't really see a lot of the concern other than, okay, you'll have to provide RBAC, but the RBAC is constrained. It's just bucket access requests, bucket access buckets, and then secrets in this namespace. So it's fairly well constrained.
Yeah, makes sense. Yeah. That's why, you know, I was asking the question earlier, is this really a big concern? I think John also is saying the same thing.
No, I think we're all saying the same thing at this point.
Mm-hmm.
And we're saying pretty much what we said 2 weeks ago too. So if I'm wrong on that, please speak up now. Otherwise, I think we can move forward. I think we all agree that the RBAC right now, not a huge concern. It's limited in scope, and it applies to code that we're going to own to begin with. Okay, so moving on to the next point in the recap, we we debated a bit about the process of turning a greenfield bucket into a shared pseudo brownfield bucket. The process we kind of discussed to make this happen was to enable administrators to edit a permitted namespaces list on the bucket cluster object after creation, or if it's brownfield to begin with, at creation. And then B, to enable users to pick bucket classes, which would have an additional permitted namespaces slice, which would also specify namespaces. This would give administrators the ability to define sets of namespaces that should have access to the bucket. It doesn't give the user innate control of provisioning operations, which was a concern. And this is, at the end of it, we had sort of 3 separate states that a bucket API object could be. So if it's private, its permitted namespace list would just consist of the originating bucket request. If it was created from the bucket class, it's a kind of pseudo brownfield and shared, and then that would be a concatenation of both the originating bucket request and the list of the additional namespaces, and then a public mode defined as, you know, a asterisk or some other, you know, character we define, probably an asterisk in the field name, indicating that any namespace can access this bucket. The follow-on conversation for that was deletion operations. How do you handle cleanup of these, you know, green to brown buckets? For the case of actual, you know, retain policy delete, we'd gone back and forth on whether or not we should maintain a list on the bucket of attached requests, but there's a lot of issues in that with race conditions and upper limits on the actual size of the bucket object. And then a count also, you know, just maintaining a simple counter doesn't really make sense either in terms of accuracy and race conditions and the asynchronous way in which it would be handled. So the consensus at the end of the meeting was for a delete operation on greenfield buckets, the cozy controller will query all bucket requests in the cluster and determine which ones have a reference to this bucket, and also has to be checked against the permitted namespaces. And pending that, if there are no requests for this bucket or that reference this bucket, the deletion operation will continue. Otherwise, it will block until all requests are gone. We still acknowledge that there's some race conditions here, especially at the case where there's one request and then 0 and then 1, created in the interim of the delete. That's something that we have to kind of suss out with some prototyping. Does this sound familiar to anyone, or are there any questions or anything that come to mind before I move forward? Okay, if something comes up further on, just please feel free to bring us back to it. So now I have some actual questions. Some of the updates, let me enlarge this for y'all. So current state of code, we have 2 repositories in Kubernetes SIGs now, the Cozy CSI adapter and the Cozy spec. I'll share these slides out after the meeting on the work group, Google group, so you have access to these links. Currently, there's no code in there. And my question for Sid and or Ching, if they're here, are these for us to use for prototyping and spitballing code, or should these be considered release code bases?
I mean, I think we're fairly certain on how we want to build this. Are we still prototyping? Can we not start contributing to these repos directly?
Do you need to get the KEP merged first? Because normally you need to get KEP merged first. Then you start submitting PR to those repos, right? That's normally the process.
Okay.
I think so. Sad, do you have other suggestions?
That's right. First, we need to get the KEPs approved, and once the KEPs are approved, then we're unblocked for actually beginning to merge code.
Great. Okay, that answers that question pretty succinctly then. So on that note, we have an unofficial workspace right now. Organization is called a Container Object Storage Interface, and we have a number of repos there. Some are being developed in right now. I have a PR open in the Cozy CSI adapter. The work for that's about 80% done. It was pending some work on the Cozy API. That's been ironed out sufficiently that I can continue work on that PR. We also have the gRPC spec that is being developed. The create and delete bucket interfaces, I believe, exist or are being ironed out. There's not any code yet in the controller manager. Sid, did we have someone working on that? I forget now if we actually asked someone to begin that.
Was that me? I'm not sure.
Okay.
Yeah, I thought Sidecar was the one that's unassigned. I'm not sure. I'll have to go look at the project board.
Okay. Yeah, no worries. We can figure that out.
Okay, we might want to do something about the unofficial org. It might cause issues in the future, so I don't know if we want to maybe at a minimum put a notice on there or something, or even delete it altogether.
Yeah, that was going to be my question. Can we copy over code or just take the code from the unofficial and put it in the official ones? I'm guessing that's not possible, right?
Yeah, pending KEP acceptance, right?
Yeah, I don't know what the.
Are you, Saad, is it concerned the name?
It's not the name. I think it's the kind of IP ownership issue,
Mm-hmm.
because technically it's not a repo that is owned or an org that's owned by the CNCF. And I wonder if you kind of copy and paste any code, if you have any, I'm not a lawyer, so I don't know the answers to any of that.
Right, and that's where we get into some issues, right? Because we need a common workspace to develop on and review.
Yeah, and ideally, I mean, what we would do is for these repos, kind of make you admin on them so you can iterate quickly and get things merged and kind of move at your own pace for the official repos. And that way you wouldn't need kind of a side repo. And if you needed something on the side, you could use your own personal GitHub. I think that should be fine. Or maybe even if you put like a notice on the unofficial one to say that, you know, this is just a working space, go to the official repos here or something. I don't know. Might be worth following up with someone from the CNCF on that.
Okay.
Do you know who?
I can put you in touch with Chris if you send me an email, and then he can help you sort it out.
Srini would be.
Yeah.
Srini, could you take care of that?
Yes, definitely. And Saad, I'll pin you and then
Perfect. Yeah, send me an email. Thanks.
On that note too, so we're also going to be iterating on, controller manager sidecar. Should we ask to have those repos created now, or are we? I guess that's still the question, right? Like, if we're not going to be pushing code into this until the KEP is merged, are we just kind of looking for a process by which we can work unofficially and then merge it in, or push this code into these repos after the KEP's merged? Is that what we're talking about here?
We can do personal repos until we have the official ones, I guess. It depends on what Srini finds out. If he finds out that it's okay for us to work with the unofficial ones, we'll do that. Otherwise, we can do the personal one.
Gotcha. Okay. So that satisfies that. And then again, I'll send these slides out, so you'll have access to these links. Feel free to review the code and chime in on PRs and things. So next up, speaking of the getting the KEP merged, we need to define our graduation criteria for this. So far, we don't have really a section for that. Some things are obvious, of course, a crystallized API that we agree we can move forward and code against and iterate on. But beyond that, there are things in a new sort of KEP format that have come out since this document began. And it calls for things such as, test plan, upgrade downgrade strategy, version skew. To what degree do we need these in the initial document? And how much do they hinge on getting this KEP merged?
I think I don't know the answer to that. For an alpha level KEP, I think all of these are required, but if we call it like prototype or something, I think we may be able to get away with less. I'd need to go and look at the official guidance.
Okay.
If you read that template, I think it says what is for alpha, what is for beta. So you need to fill out those that says alpha, but then I think it's not all of them.
Right. I'll go back and take a look at it. My recollection was that these are all requirements, but we'll see. I'll go back and give it a more thorough read through, and I'll pose the question on the.
So it looks like scalability is not required for alpha, at least on a quick glance at that template. And the other interesting thing is, I don't know if they have anything less than alpha in terms of a KEP target.
Yeah, they
only see alpha, I think. I don't see anything I don't see a pre-alpha in the KEP.
The earlier criteria was a little more loose in terms of, what can be merged. So yeah, but
do we want to target an alpha for the next Kubernetes release timeframe? for the 1.20 time frame. And in that way, we could kind of focus on getting a alpha level KEP merged, and then have kind of the work aimed towards getting an alpha quality out the door.
I definitely think it'd be good in motivating, you know, progress in the implementation of it.
Mm-hmm. In the worst case, we could push it out from the 120 time frame to 121.
Mm-hmm.
What's the timeline for 120?
So 120 should actually be end of year. Normally that's at the quarter boundary, but this year, because of the coronavirus, we're doing 3 releases. And so 119 got kind of pushed past into Q3. And so 120 will be probably closer to the end of Q4.
Yeah, sounds reasonable.
If I understood that correctly, that's alpha in 120.
But let's target that. And if we hit it, great. If not, we can push it back. I don't think it's a huge deal if we end up pushing it into Q1.
Cool, thank you.
Okay, and then we'll just derive the graduation criteria from the KEP template there. Then I think.
And it might be worth kind of breaking it down into smaller milestones as well, because you have the spec, and the spec kind of can be released or needs to be released before any kind of integration, right? So you could target maybe like a 0.1 of the spec by end of Q3 or something like that.
Yeah, I definitely think that's reasonable. Are we, when you say break it down like that, are you talking about maybe opening up a second KEP for just the spec, or are we talking about just having a spec ready for into Q3?
Just having, in terms of like work pacing, kind of
Okay.
internal targets. You could still use, I believe, a single KEP for all of it.
Okay, cool. Yeah, that's definitely a lot cleaner. Okay, so that answers all the questions I have on that, I think. Let me move forward. Deletion considerations. So going back into implementation a little bit, there were a couple of open questions that we didn't get to in the previous meeting. And so in the, just to kind of run down these use cases here, they're pretty common, but there's some things that haven't quite been answered. So take number 1, you know, in the common greenfield deletion case, right? Delete my bucket. I expect my bucket and the storage to be deleted because my retain policy is delete. In cases where we have petabytes of data that could take days and days to delete, how do we account for asynchronous deletions in this case? We don't want the cluster to hang on to that bucket object, I don't think anyway, for the period of time it takes to delete something, if that can run.
Is that what happens for cloud providers today? If you have a very, very large bucket that it takes a very long time to delete, or do they give you an immediate, yeah, it's deleted and we'll delete it on the back end kind of thing?
It takes a really long time. The slowest operation is listing. So they'd have to list them and delete.
Interesting.
I can only speak for AWS and Minio, actually. I don't know about Google storage buckets or Azure. I'll have to look it up, to be honest.
It's on our roadmap for Storage Grid to be able to do bulk deletes without doing the list and delete.
Okay, that's cool.
So, John, you were asking like how to find the policy. Maybe retain policy could have, you know, async delete versus sync delete. I don't know. If someone wanted to force a synchronized delete before the resources were cleaned up on the K8 side. I don't know. Just thinking out loud.
Right. Yeah. The question falls down on kind of 2 separate points. One, is it the responsibility of Kubernetes to handle this, or is this something we just expect drivers to be implemented to do cleanly and allow Kubernetes to move forward? If it's a Kubernetes responsibility, how can we signal to the driver that we want to do an asynchronous delete, that we expect this delete to take X amount of hours, do it in the background and let us move forward? And should that be something that we even do, or should we keep the API object around until the bucket is actually deleted? So I guess.
So we had a big discussion on synchronous versus asynchronous for CSI, and ultimately landed on synchronous is a much easier to implement design. And the thought also was that synchronous can capture the asynchronous use cases in kind of a ugly way by just polling. And at least for the CSI side for volumes, you know, that was sufficient. But if you're talking about an order of hours to be able to delete a bucket, and that's kind of a normal operation, it may be worth considering asynchronous, but that will certainly complicate the design a lot more.
When we say asynchronous deletion, obviously I understand what that would mean on the service side. What would that mean on the Kubernetes side?
So the way that I think of it is that the RPC call blocks until the deletion is complete.
That's
okay.
Synchronous.
Oh, sorry.
Yeah.
You said. I'm sorry. You said asynchronous then.
Asynchronous. You're right.
Yeah. Okay.
So that I would assume that would effectively putting a deleting status on an object or something, and then at some point later it actually gets deleted or something like that.
Well, effectively the difference would be the sidecar that's responsible for deletion, like in CSI it's external provisioner. Instead of having a blocking RPC to delete that waits there until the deletion is complete, it fires off this asynchronous delete and says, you know,
which would be idempotent, and it would come back and say, here's the object, it's still being deleted, right?
Right, and then, I mean, that's the case with synchronous. So synchronous is already idempotent. And so, you know, it doesn't give you an operation ID back, but it's assumed to be idempotent. And so if, you know, you have a connection failure or something, you can always retry it and get the same result back, no problem. Asynchronous, I think the difference would be either you get the operation ID back, or you provide a kind of endpoint that the receiver can call back on when the operation is complete.
Hey, Sad, so for snapshot, we are actually already dealing with this problem because we need to upload, right? So like we call create snapshot, which is synchronous when it comes back, when the snapshot is cut, then we call, well, right now we actually call create snapshot repeatedly to find the status.
Got it. So it's get some sort of operation ID and then pull.
Yeah.
I think that
I don't
would
think
be
it's based on an operation ID though, right? Is it based on operation ID or the same original item?
For create snapshot, it's actually not really giving you back. It basically you just give the same, you make the same call again and again because it's idempotent. So it's supposed to give you the same results from the same snapshot. So you should not be creating a new one. And we do also have this list snapshots, which just can query the status. But because that is optional, so for dynamic provisioning, we're actually just calling create snapshot.
And does that work well for Snapshotter?
Yeah. So for list snapshots, we only use that for static pre-provisioned snapshots. We use list snapshots. But for dynamic provisioning, we only use create snapshot. So
maybe we could follow that model then, which means keep it synchronous. And of course, this entire API requires all RPCs to be idempotent, which means that at any point, the caller can reissue the same RPC and expect the same result back. And so effectively.
So to be clear, when we say, this is why I was saying, what is our definition of synchronous versus asynchronous? So you're saying that the RPC is synchronous, but the actual underlying operation may not be complete. So it might be a long running operation that you do multiple synchronous calls against until one of them indicates that it's done.
Right, and even going a step further, the expectation could be that it will block until the call is complete, but for these long-running operations, it's going to hit the timeouts, network timeouts fail, and then will be retried by the caller. So the logic from the caller is kind of dumb and simple. It assumes synchronous blocking operations, and it has the logic to retry if things fail. And that's, you know, basic logic on the client side. On the server side, you just need, you're going to be required to make these things idempotent. So if you get a delete call for bucket foo and you're unable to complete it before the request terminates, if you get another request to delete foo, you don't restart that, you continue the existing request.
So that's fine from a correctness perspective, but the downside is the amount of time that things will actually take will end up depending on what your retry cycle is. If you just miss a timeout somewhere, like if the retry cycle is every 1 minute and it takes you 61 seconds to delete it, it's going to appear to take 2 minutes from the user's perspective, and that's.
Yeah, I think on the Kubernetes side, we do exponential back off to 2 minutes. And then after 2 minutes, it's just 2 minutes fixed.
That seems pretty reasonable in this case, because we're talking about things that can run for hours. So at that point, you have this sort of the scale of the wait for an operation that could take 3 hours. If it's 2 minutes, then that doesn't seem like
you're going to end up with like 30 calls for that hour.
Yeah,
a little bit more.
So we could define a higher limit and a larger step.
And to Ben's point, if it ends up being a problem in terms of like, we're not setting the right back off time limit or something, we could consider making that negotiable between the driver and the client, though I would like to avoid that if we can.
Yeah, but even his example, if you have an exponential back off that tops at 2 minutes, that means anything that is taking 2 minutes or 3 minutes, you're going to capture more fine grain than that. It's only when things start to take multi-minutes that you're going to miss by an interval. And then your worst case is probably sort of the 5 to 6 minutes. You might overcount by a couple of minutes. But then after that, it starts to be a diminishingly small part of the overall time.
Yeah, exactly. So it sounds like this is something that we need to prototype out and tune to just get an idea of what it looks like.
It seems like it's worked fairly well on the CSI side, so let's try to follow that model, and I think a prototype would be a good way to prove out if it works or not.
Yeah. Okay.
So I'm sorry, I want to ask a little deeper in the model of that you expect this to work on, because it felt a little bit weird to me. Let me explain what I was expecting and then what I think you're saying. What I was expecting is you would issue a delete and it would return right away and say, yep, I'm deleting it. And here's the state of the thing. It is being deleted. And then I would, at some point later on a reconcile loop, I would say, oh, I need to delete this thing. And either I could say, well, it says it's currently being deleted, therefore I've got no action to take. Or no, I do have an action to take because I need to query it to see if it has been deleted. But I could just model that as attempting to delete it again, and then rely on the idempotency constraint and the driver to line that up. And so if it's capturing an operation or whatever. But it sounds like what you're saying is instead, I will issue a delete and I don't expect it to return right away. I expect it to time out if it isn't able to finish the delete. And then I consider that sort of an error, and I just keep retrying.
Right. It's basically a simpler way of implementing what you're proposing. And from the client side, you know, it doesn't need to special case this, and it'll just hand it. The assumption is that all these calls have to be idempotent. And so if we're going to have that requirement anyway, instead of requiring an additional kind of operation ID to be passed back, we can just reuse that existing mechanism.
Okay, I guess.
Also, drivers have the option of, if they know it's going to take a long time, they can just say, I'm not done yet immediately, and you call me again later. You know, you don't have to block.
Yeah, that was the part that I guess I was reacting to is this idea for very long running operations that we expect to be long running, that we expect to kick off asynchronous processing. We don't expect synchronous. It seems weird to me to model it as I'm going to attempt it to be synchronous, and then I'm just going to have multiple levels of failure.
Well,
because then
the multiple levels of failure can always happen. So that the idea here is it lets the driver implementer decide if they want to block or immediately return an error. It becomes an implementation detail for them because the sidecar will behave correctly in either case.
I guess my problem is I don't consider it an error that I wasn't able to complete the deletion in a short period of time.
But effectively, does it matter, right? Like if you had a network dropout.
Well, it matters from an operational perspective. If I'm looking for events or other kinds of error messages on this, and I, as a system administrator, I'm saying, oh crap, I can't delete my bucket.
Yeah, it is worth mentioning that, like, yeah, with the existing CSI model, you do see like errors in your logs when these things take a long time, but
that's a fair point.
Or warnings at the very least.
So I think for create snapshot, it's a little different because there are actually two phases. The first phase actually is blocking until the snapshot is cut. That really should not take long. That comes back, and then we call create snapshot again, and then that should tell you should check the status and see if upload is completed or not.
For so create snapshot in particular, that's true. But like if there was a delete that took a long time, you would this behavior would happen with CSI.
We don't have that problem. For delete, we actually don't have that problem. It's just a synchronous call.
Well, right, but if there was a backend that took 10 minutes to delete a volume,
then we
this would happen.
That's why we add those logic.
I'm actually agreeing with Xing that this problem more accurately is compared not to deleting a snapshot, which we expect to be a metadata operation that's fast, but it's more akin to those snapshot implementations that involve an upload phase, right? Where that upload could take an arbitrarily long period of time. And I think what you're saying is that part of create snapshot is not considered a failure when it hasn't happened. You just effectively poll it periodically.
Yeah,
we basically
the driver returns a success with one of the fields set to false. And
the difference there is that we do get a kind of status update periodically that the user can look into.
And that's exactly what I'm suggesting that we do with this.
So right? I mean, can the logs be exactly that, right? Like if you have a long running process and you know the receiver is unable to complete it within a requisite amount of time, they return an error and say, you know, process is taking a long time, still in process or something. That gets logged out.
Yeah, I'm suggesting that a savvy driver could actually say, still deleting, have deleted 3,000 of 4,500 objects or something like that. So that you could have something that doesn't look like an error, it looks like a updating status message.
And that's fine, but what if you stuff that information into an error? Like, why do we need a whole mechanism around this, a first class mechanism?
It's a question of what shows up in your logs. So
yeah.
Errors tend to irritate people and think something is wrong.
I mean, why we shouldn't do control flow with errors in general? Trying to see how the phase or status of it using errors. It's just not idiomatic.
I'm taking Saad's position as the error-based mechanism works today, and that if we were to do a more sophisticated kind of like the way snapshot creation works, it would require somewhat different / more sophisticated model, and that's your concern?
That's basically it. It's just simpler and easier to implement if it's just purely synchronous. But
Well,
I can buy the arguments for the UX not being great if you're using errors and having your logs fill up with errors saying timed out, timed out, timed out.
It's also worth understanding that even if we have a more sophisticated mechanism, the error-based mechanism still has to work.
Yeah.
Because that will end up happening inevitably. But
Yep.
yeah, you could have a successful return with some status that says I'm not done yet, which makes for more stuff in the API, but less log spam.
So I guess the question is, how common is this? It sounds like based on what you all are saying, this is fairly common for it to take.
It's my experience, yeah, that if you've got a bucket with any reasonable number of objects in it, it basically clears the bucket first and then deletes it, and that can take a long time.
Okay, so I guess I can go either way. I can be convinced that this would require a more kind of the operation-based approach where you have a call for delete and it immediately returns an operation ID, and then the caller can use that operation ID to pull the operation status.
I don't think you need an ID. You do the delete, and it says delete progress, started, not completed, and the caller just does a status update and then recognizes that they need to try again later. Or if they time out, they do the same thing, but they just takes longer and you get an error message.
I think that seems reasonable.
When you're looking at these things from the reconciliation point of view, though, at some point you exceed the overall timeout, right? And the event is DQ'd. It's like
there is no.
But we need to make sure that we configure that appropriately, right? Like if there's
really the case for
what's that?
So there is the attempt to delete an object, and then there is a request to implement a delete operation, right? So if you distinguish between the two, I mean, there's no upper bound on how long it can react to status, right?
Right. As long as because Kubernetes kind of continuously reconciles, so it's going to keep retrying as long as the objects exist or don't exist to try to achieve the state that's desired. So you're right.
Oh, so John, I thought I had read, so it sounds like I'm wrong, but I thought I had read that there was the API using the, like controller runtime or something like that, that there was an end of trying type period where we've retried and maybe and done exponential backup and on, and at some point this operation just isn't going to work, and the namespace / resource name is DQ'd. It's just not on it doesn't get put back on the work list. Is that I'm misunderstanding?
I think that it's only dropped from the work queue if no errors are returned. Otherwise, at least in like the boilerplate control.
Okay, so as long as error is non-nil, it will continually try to reconcile.
Right, and it'll just keep requeuing it on a kind of a rate limited back off.
Okay, never mind then, sorry.
Okay, so I'd like to leave that topic there for now, given that we're coming to the top of the hour. And the last thing, unfortunately, so I am being moved due to a little bit of a reorg with inside Red Hat, so I'll be moving off of storage, taking over responsibilities I've defined the roles here as administrative and technical. I don't know if admin is the best name for it, but Aaron and Jeff from Red Hat, who have been attending all the meetings, are going to be taking over, KEP documentation updates, shepherding the KEP through the overall review process. They're going to be setting the agenda for the meetings like I've been doing, and bringing up technical discussions and design discussions. and then collaborating with Sid. Sid, I've asked to take on a technical leader kind of role here and getting the code implemented, making the kind of deep down design decisions and helping surface the unforeseen, blockers, edge conditions, things that we couldn't have predicted back up into the KEP review meetings. Sid will also be running weekly Monday stand-ups and soliciting help from community members, to help meet technical needs here. So I'll be available in sort of an unofficial stance in terms of consulting on, design ideas. If there's things in the KEP that don't make sense and I'm needed for sort of some historical context, I'm happy to talk about that. But starting Monday, I am going to be shifting off pretty much entirely.
That is really unfortunate, man. You drove this project to where it is so far, so it's sad to see you go.
Yeah, I appreciate it. Yeah, and then thank all y'all for your interest and your support over the months that this has been going. I really appreciate that. And
well, thank you for all your hard work on this.
Your work is
man.
appreciated.
Bummer to see you go, man.
Yeah, thank you for the sentiment. I'm look forward to working with y'all in the future on other projects for sure.
Yeah. It's a good opportunity for John. A lot of times he's been on this. We certainly don't want to lose momentum, and I think the timing is reasonably good that we have some other people like Sid really stepping up, and he's even run one of the meetings and a good technical understanding. And we want everyone that's been participating. We've had over 20 sometimes in these calls. We definitely want to keep the momentum going, keep the community participation up, and drive this to the finish line. We're close, and we don't want it to stall out. Any help we can get to keep the momentum up will be very appreciated.
Yeah, thanks, John, for bringing it this far. A lot of the tough questions have been answered, and we've established a good cadence as of now. We have Rob working with us. I don't know if he's on the meeting today, but just like Jeff was saying, if more people can contribute, that'll be good. We have a lot of interesting challenges to solve, and yeah, everyone's invited.
Cool. Well, thank you so much for your leadership, and I think we can recruit more folks on the regular SIG storage call as well. I know this is going to be difficult with kind of a big contributor dropping off. So.
Yeah, Saad, you're right. I mean, just sort of broadcasting it to a bigger group that we can use some help now. There's a good reason for it, and maybe we can get some more people.
Yeah, definitely. Feel free to put an agenda item on the next SIG storage call.
Great.
Okay, we are over time here. I hate to leave it on a down note, but again, I appreciate it. I've really enjoyed working with you guys, Jeff and Aaron and Sid, and the rest of y'all. I know you guys have a great understanding of this, and I know that we're in a pretty good shape with it. I don't think we're going to lose momentum, given how far we've come with it. On that, I will say goodbye and thank you all for attending.
Take care.
Yeah, John, thanks. Bye, everyone.
Bye.